At American Holt, we utilize 3D printing technology for a variety of applications, including casting, fixturing, and prototyping. We apply both FDM and SLA printers in our workflow. FDM, or Fused Deposition Modeling, is a ubiquitous method for desktop 3D printing. It functions by melting spools of plastic filament and extruding the plastic onto a flat surface to build up an object layer by layer. FDM printing is highly versatile, can accommodate a wide selection of printing materials, and is relatively inexpensive to operate. SLA, or stereolithography, is the oldest form of 3D printing and is used in many high-precision applications. Prints are formed by exposing liquid resin to light in order to harden. Like FDM, these prints are built up layer by layer. SLA printing can have very high resolution, which enables parts to be printed with extremely fine detail and to have notably smooth surface finish with little post-processing. The prints also tend to have good engineering application due to their isotropic nature, making them equally strong in all directions. A primary use of our 3D printers is small batch investment casting. Investment casting involves creating a pattern out of sacrificial material, which gets coated in ceramic and then burned away to create a mold for molten metal. Our FDM printers are used for this process due to their ability to quickly print hollow patterns with specialized material that will burn away easily, all for a low cost. Both our FDM and SLA printers can also be used to generate reusable patterns for sandcasting processes. Engineering materials also allow us to develop functional prototypes. Using 3D printing allows for quick iteration in the design of a part. High-detail prints can be used to check how a new design will fit amongst existing components. Prints made from specialized materials can mimic how a final product would perform under realistic loading and environmental conditions.